Ireland and or Arianda. I got your email, and you should have gotten my response, but I said I would add some more today. So this is the additional instruction, let's say. So clearly you are working on a linear programming problem, and you didn't ask for help on the whole linear programming problem. You just asked one particular thing. How do they come up with the graph of that line, which I'm going to explain. But understand the reason that we're graphing all of these inequalities is so that we can figure out the shape and the corner points for the domain of the function that we have to evaluate. And once we know where all these lines are, then we're going to use these points, 0, 200, 300, 200, 450, 100, 450, 0, and 0, 0, and plug them into an equation. I can't even see if we have that equation here. Well, you could probably figure it out. So in any case, how do you come up with this equation, this graph on the line, this line on the graph? Sorry. So remember, I don't know how far back to go. So I'm just going to go a little bit far back just to say, when you graph an inequality, there's two things that you have to graph. One of them is going to be a line, right? And the other is you're going to shade one side of the line or the other, right? In this case, we are talking that the boundaries are straight lines. And you can see the difference between the one on the left and the one on the right is one of them has a dashed line and one of them has a solid line, which we'll talk about in a minute. But then only one side of that line is shaded, meaning is part of the solution, right? Only one side of the line is shaded. So that's what we look for when we're graphing an inequality, which is what they graphed on the page, right? So for example, if I had to graph y greater than 3x minus 1, the first thing you have to do is graph the boundary, right? Graph the line, which is, change color, y equals 3x minus 1. So in that form, which you should recognize, this is slope-intercept, right? This is y equals mx plus b. So the first thing you graph is the y-intercept is -1. So they have the y-intercept of -1, and then they use the slope of 3 to find another point on the line, right? If the slope is 3, that's like 3 over 1, which means go up 3 and right 1. Up 3, right 1. There's another point on the line. Let's draw the line. Now, in this case, because this inequality was greater than and not greater or equal to, you use a dashed line, right? It means that the line itself is not part of the solution. Kind of like on a number line. If you remember, on a number line, I could have 1 and 3, and if I use open circle, it means that it's not included in the solution. If I use closed circle, it means it is. Right? That's like 1 is less than x is less than or equal to 3. So open circle, closed circle. In terms of graphs in the coordinate plane, it's actually going to be solid line, dashed line. Okay. Now next, after you know where the boundary is, you need to know where does the shading go. And when it's solved for y, like yours up here is solved for y, then if it says greater than, then you shade on top of the line. If it says less than or equal to, you shade below the line. So in this case, here's the line. I think you can see that. So above the line is what's shaded. Or another way to tell where you're going to shade is to take a test point, not on the line. So if I look if I look out, and I'm on this first graph now, if I look out somewhere on the graph, which is not on the line, and just take that point, -2, +2, and plug it into the inequality. Right? In this case, it would be 2 is greater than 3 times -2 minus 1. So 2 is greater than -7. If that's a true statement, then you want to shade the side of the line that includes that point, right? Shade it all there. If you got a false statement when you plugged it in, you would know to shade on the other side. But we got a true statement, so we shade on the side that we took our test point. Now, in this example, and I'm just copying graphs that they have in the book, they use 0, 0 to be their test point. And 0, 0 makes all the calculations pretty easy as long as it's not on the line. And even though it's pretty close to the line, it's not on the line. So they used a test point of 0, 0. So if you plug in 0, 0, you could probably just hear that bell, right? Do you miss the school bells? Okay, now if I plug in 0, 0, I get 0 is greater than 3 times 0 minus 1. 0 is greater than -1. So they tested 0, 0. It led to a true statement, right? So they shaded on the side of the line where their test point 0, 0 was. Here's the example of a or equal to. This is y less than or equal to 3x minus 1. So it's the same boundary, right? Y equals 3x minus 1. But in this case, because it's or equal to, you use a solid line. Okay, and now if I use a test point, if I plug in 0, 0 for this one, I get 0 is less than or equal to 3 times 0 minus 1. 0 is less than or equal to -1. That's false, right? That means you don't want to shade on the side of the line where the test point came from. You're going to shade on the other side of the line. Shade over there. Okay, now, if you understand that this is solved for y, then you could have just looked at that less than or equal to. Since it's solved for y, less than means below the line. And so here's your line, just shade below. So in either case, you get the shading where it belongs. Now, in your problem, you don't have a line which is in slope-intercept form for graphing. You have it in standard form. And there's a slightly different procedure which we use to graph a line which is in standard form. That is honestly, we use it in linear programming. That's one of its most useful places. This is a standard form line. A standard form is ax plus by equals c. And we know it takes 2 points to graph a line. In this case, we are going to find 2 particular points. We're going to find the x-intercept and the y-intercept, and then connect them with a line. So the x-intercept is where does the graph cross the x-axis. The y-intercept is where does the graph cross the y-axis. And we use the fact that on the x-axis, y equals 0. And that on the y-axis, x equals 0. So if you want to find the x-intercept, substitute y equals 0. 4 times x plus 3 times 0 equals 24. 4x equals 24. X equals 6. Right, so this is the point 6, 0. So go 1, 2, 3, 4, 5, 6. Right, to find the y-intercept, you substitute x equals 0. So 4 times 0 plus 3y equals 24. 3y equals 24. y equals 8. So this is the point 0, 8. So go up 1, 2, 3, 4, 5, 6, 7, 8. Didn't make that quite high enough. Now, with 2 points, I can make a line. There we go. Now, I will say that most of the time, if you're doing this at home and you're doing it on paper, I usually do more like this, and I'm going to show you with. I'm going to show you with the screen here, but you're going to probably do this with your finger on your paper, and that is like this. When you have the standard form of an equation, it's in the standard form of a line, then usually just like with your finger, cover up the 3y, right? And then what's left? 4x equals 24. So just very quickly, you see x is 6, and you want to find the y-intercept, and cover up the 4x. 3y equals 24, y equals 8, right? You don't necessarily show all this stuff down here. You just do this, right? Find the x-intercept, find the y-intercept. Graph them really quickly, sketch a line. I mean, most of the linear programming problems, they're in standard form. So this makes it really, really, really convenient to graph using those procedures. So for example, in your problem, here, let me make myself a circle. But we want to graph the inequality 600s plus 900c less than or equal to 360. And understand in this case, we don't have an x and a y axis, we have a s and a c axis. And we want to solve, we have to graph the boundary, which will be 600s plus 900c equals 360, 1, 2, 3. That looks right. Okay, and I'm going to do that by this method. Again, first I'll find to find the s-intercept, I'll cover up that. And I'll say, okay, then s equals 360,000 divided by 600. Right, and what is that? Drop the 2's. That's 60. Okay, to find the c-intercept, we're going to cover that up. And so the c-intercept is 360,000 divided by 900, which is 40. Right, so on the graph, to graph the boundary only, right? On the s-axis, I'm going to go to 60. This is 10. So each one of these is a 10. 10, 20, 30, 40, 50, 60. And on the c-axis, I'm going to go up to 40. Again, that's every one is 10. 2, 3, 4. And then I'm going to connect them with a line. Now, I am doing this in order to solve and graph an inequality. So really, I shouldn't be graphing that line until I've determined whether I want to make this solid or dashed. And in this one, because it's, stop that. What was I trying to do? Because that is or equal to, it should be a solid line anyways. So that is the right line. Now we got to determine which side of that line should we shade. And that may be, at that point, it may not be your issue anymore. It may have been more just where to draw the line, right? But clearly 0, 0 would make a good test point to determine. So if I plug in a 0 for F and a 0 for C, then I have 0 plus 0 is less than or equal to 360,000. And that is true. So the shading should be on the side of the line that has 0, 0 in it. So that is where they got their line. Let's go back and look at their line again. Right, so you could see they had the S-intercept of 600, the C-intercept of 400. They connected with a line, and their shading is inside like this. So I hope that that explains where they got their line from, and maybe even, went back and touched on a few things that might help you out. So let me know if there's anything else that I could do for you. I like to do